Hello everyone, how are you all? I am Dr. Nandita and today in Aptdemy's live session I would like to welcome all of you. So today I am here in this live session to solve some very interesting and some typical problems on the chapter of organic chemistry, aldehydes, ketones and carboxylic acids. But before I start to solve the problems, let's just talk a little bit about the compounds and their usefulness in our day-to-day life. So, yeah. So, these are basically the compounds which contains carbon double bond O, right? And so also they are also known as carbonyl compounds. In aldehydes, the carbonyl group is bonded to one hydrogen and one alkyl group, right? Or maybe one hydrogen and one carbon. Whereas in ketones, both the carbonyl group is attached to both the carbon atoms from both sides. So this is your aldehyde and this is your ketone. You can also name this compound as acetone. Whereas carboxylic acids are the compounds in which the carbonyl group is attached either in one side with either carbon or hydrogen and in another side with oxygen of hydroxyl molecule. So it could be like RCO OH or maybe HCOOA. So from one side it is attached to either carbon or hydrogen and another side it is attached to, this carbonyl group is attached to oxygen of hydroxyl molecule. So this is your carboxylic acid. Whereas if this oxygen is replaced by, similarly by NH2, or you can say that if the carbonyl group is attached to either hydrogen or carbon at one side and attached to nitrogen of NH2 moiety, it is this kind of compound is called amide. In place of NH2, if you put X, for example, RCOOX, where X can be your any of the halogens, can be chlorine, bromine, or iodine, and this compound is called acyl halide. Right? So all of these are examples of carbonyl compounds. Now, there are some compounds available which are known as the carboxylic acid derivatives. They are known as, for example, if you have the formula RC double bond O, this is one of the carboxylic acid derivatives which is known as esters, or another one is also available which are known as acid anhydride. Right? So these are all the examples of carbonyl compounds. Now these aldehydes, ketones and carboxylic acids are very useful in our day-to-day life. They all are widespread in plants and animal kingdom. They play important role in biochemical processes of life. And also they add flavors and fragrances to nature. For example, if you take some of the carbonyl compounds, for example, this is your vanillin, This is one carbonyl compound. Another one could be salicylaldehyde, and another one could be cinnamaldehyde. These are the examples of some of the carbonyl compounds which are having very sweet and beautiful fragrances. So they are used in our day-to-day life. How they are used? They are used for adding flavors to some of the food materials and also to some of the perfumes. And also they are used in pharmaceuticals, right? Some of the carbonyl compounds may be used as solvent. For example, acetone, right? And there are many other carbonyl compounds which are actually used to manufacture adhesives, perfumes, resins, paints, and some plastics, fabrics, and so on. So from the examples I have given you, you can easily understand that these carbonyl compounds, for example, aldehyde ketones and carboxylic acids and their derivatives, how important they are playing role in our day-to-day life. So without them, we will be missing the flavor of life. So with this, let's move on to the problems. So the first problem is asking you to identify A, B, and C from the given reaction, and we have to give their structure. So let's see how can we do that. So this is the structure which is given here. Now from the reaction you can see that this is the haloform reaction. In presence of bromine and sodium hydroxide, haloform reaction is going on here. So this is your haloform reaction, right? So if haloform reaction is taking place with this compound, what will be the result? Result would be two. There will be two products which are formed during this haloform reaction. One is the, I'm sorry, this won't be here, this will be here. So we will form the sodium salt of the carboxylic acid, right? So this is our A. Product A which is formed, which has been asked here. Another product which is formed during this reaction is CHBr3. So sodium salt of carboxylic acid is formed here, and also bromoform is formed. So this is named as bromoform, right? This is our B. Now protonation will happen with product A. So if protonation will take place on A, so on protonation, product A will form the corresponding acid, right? And if you check the structure, you will be able to see that this is the beta keto acid. what will happen to this beta keto acid, which is formed after the protonation? It will readily, on heating, it will readily decarboxylate to form the third product, that is the C. And what is the product? So this is nothing but your decarboxylation. Your acid group will be removed from the beta keto acid and you will end up with the product C. The name of the product is 2-methyl cyclohexanone. So this is ours. So we have already found out A, B and C from the given reactions. Now if you check the product C, you will come to know that this will have the molecular formula of C7H12O. So we are on the right track. So this is the carboxylic acid of the acid derivative of the given compound, which is A. B is our bromoform and C is on decarboxylation. Simultaneously on protonation we will form beta keto acid, and after decarboxylation we end up with the product C, which is 2-methyl cyclohexanone with the molecular formula C7H12O. So very simple. I hope you have understood. Now let's move on to the second one. Problem 2 is asking to have an organic compound with molecular formula C9H10O, which is forming 2,4-DNP derivative, reduces Tollens reagent and undergoes Cannizzaro reaction. On vigorous oxidation, it gives 1,2-benzene dicarboxylic acid. Identify the compound. So one compound which are going on several reactions with several mentioned reagents, we have to find out the particular product with the molecular formula C9H10O. Now I hope that in this chapter you have already learned about the Tollens reagent, also about Cannizzaro reaction. So because this organic compound with molecular formula C9H10O is forming 2,4-DNP derivative and reduces Tollens reagent, what can we say from our understanding is that this group, this compound with formula C9H10O must contain a CHO group in it, right? Because it is undergoing or it reduces Tollens reagent and forms 2,4-DNP derivative. So one thing we are sure that it contains a CHO group. Now secondly, what can we say that because it is undergoing Cannizzaro reaction, so what will happen? This CHO group must be attached to a benzene ring, right? So because it is undergoing Cannizzaro reaction, this C, which indicates that CHO group is attached to a benzene ring. So this is an aromatic compound, right? Number 3 is on vigorous oxidation, it gives 1,2-benzene dicarboxylic acid. We have to identify from this. So because on oxidation it gives 1,2-benzene dicarboxylic acid, what can we say that this compound with molecular formula C9H10O is our ortho-substituted benzaldehyde. Right? Which on oxidation will give you 1,2-benzene dicarboxylic acid. So ortho-substituted aromatic aldehyde with molecular formula C9H10O must be of the following structure. So we have already identified the product. What is the name? Ortho-ethyl benzaldehyde. We have already identified the structure of the given compound. Now, one by one, I will show you how this compound is satisfying the conditions which are given in this problem. So now, if you consider this orthoethyl benzaldehyde, and now if it is reacting with the tolerance reagent, which is AgNH3 whole 2 plus OH minus. This is nothing but our tolerance reagent. It will give you the corresponding acid derivative. This is called 2-ethyl benzoate. Along with this, it will form silver, which is silver mirror. Right? So you can see that with tolerance reagent, it will form 2-ethyl benzoate. Right? Now, if you do or perform vigorous oxidation with this given compound, on oxidation it will form one, 2-benzene dicarboxylic acid. Which is already given in the problem, right? So that's how on oxidation it will form 1,2-benzene dicarboxylic acid. Now the final one with the DNP stuff. So again I am writing this structure or drawing this structure. So your 2,4-DNP looks like NO2, NO2 here, H, N, NH2. Right? So if you perform this 2,4-DNP test with the compound, what we will end up with? We will end up with CH double bond C2H5 here, and how they will connect NO2 here and another NO2 here, 2,4 derivative, and this H, N, and another N. So this is nothing but 2,4-DNP derivative along with this derivative, 2,4-DNP derivative, water will also form due to this reaction. So what the conditions which are given, I have shown. We already have identified the compound as orthoethyl benzaldehyde and all the conditions it is satisfied. So with this, I think you have enjoyed this problem, very interesting one. So with this, I would like to end this session. I hope you have enjoyed this session. Thank you very much for listening carefully. Get connected and get registered with Aptdemy. See you soon. Thank you very much. Bye bye. Have a good day.